All right, it's about that time. So before I jump into anything, let me ask you, do you have any questions? Anything you'd like to go over? All right, recording has started. Okay. Last week we were doing multiplying and dividing rational expressions. Right. Today we'll be doing adding and subtracting them. Very, very exciting. All right. I'd like to know if there's any questions that you have. Anything from the homework, anything from the past. We're still not ready for our test as yet. Test two is gonna be sometime in November. Um, if you haven't gotten your test back, I have it graded. Um, I'll see you on Tuesday to hand it back. But if not, if you want your test back a little bit earlier, and you didn't get it back yet, you could always see me in tutoring, no problem. I'm there Friday, Saturday, and Monday. Okay. Um, hope you and everybody else got their pantry for this week. You know, I don't know if it was anything good this week, but I know that it was active. All right. Saw somebody leaving campus today with a good amount of groceries, so I'm happy for them. All right. I guess I'll give everybody another like 3 minutes or so. Understand, just to like walk in or find a question, anything like that. If you have a question, no pressure, no pressure. How you doing? How you doing? He's looking for questions at the moment. I was also saying earlier, if you haven't gotten a chance to get your test back, and you would like it back a little bit sooner than Tuesday, you're welcome to see me in tutoring. I'll be there tomorrow. I'll be there Saturday, and I'll be there Monday. If anybody wants to do the test corrections, go ahead. No deadline for that. Just before class ends kind of situation. Like you would like to have it back so that you can study from it. You know? Okay. Um, Trying to see if anybody has any questions. You guys are welcome to ask right now. Anything from the old homework, not the new homework. We're gonna do that today, of course. Sure, anything at all, like ask away. Since nobody here has a question, let's jump into today's lesson real quick. And then at the end, if there's more questions, I'll take them then. But before we start today's lesson, I like to start off with a little blast from the past real quick. Okay. So here we go. Very basic, very basic. I want to add these two fractions together, right? So 7 over 10 plus 8 over 15, right? Who remembers what we have to do first before we can add these? Who remembers the process? How to add fractions? What do I have to do first? Anybody? All right. The first thing I got to do is I have to find the LCD, right? So let's find our LCD, right? So I have 10, and I know that 10, hold on one second. I know that 10 is the same thing as 2 times 5, right? And I have 15, and I know 15 is the same thing as 3 times 5, right? So remember, the way that we find the LCD, we take one of the numbers. I'm going to take the 15, which is 3 times 5, and just multiply it by, how can I say this now? By what's missing, right? So when I took the 15, I have 1, 3, and I have 1, 5, right? And I have, so I'm multiplying those together, 3 times 5. When I look at the 10 now, right? I don't have a 2, so I'm going to put 2 up here. But I do have a 5. And in fact, that's the same 5 that I had before, right? That first 5. So I can just leave it as these 3 multiplied together. So 3 times 2, that's 6. And 6 times 5 is like what, 30? That being said, I want to change the denominators that I have right now into the LCD, which is 30, right? So that being said, what number do I have to multiply 10 by to make it into a 30? What number do I have to multiply 10 by to make it into a 30? All right, it's a 3. What I do to the bottom, I gotta do to the top. How about 15? How do I change a 15 into what do I have to multiply? God bless. By 3. So what do I have to multiply 15 by to make it into 30? Right, a 2, right? So I'm gonna multiply this by 2. What I do to the bottom, I gotta do to the top. So now, what do I have? I have 21, that's 7 times 3, plus 8 times 2, 16, divided by, excuse me, the 30. Putting them together, what do I get, right? This is 6, 7. So this is 37. And that's it. Over 30. Questions on this? Nothing new. We've done this before. Mhm. All right, let's keep it moving. So, similar question. I want to subtract these two polynomials. Excuse me, these two fractions, right? But I'm forgetting something though, right? Like before I can subtract, what do I have to do? All right. So how do I figure this out? What do I have to have? Give you guys a minute to try it. All right, I have to have the same denominator, right? The same denominator. So very similar to the last problem. I'm going to multiply this by 9. What I do to the bottom, do to the top. Multiply this by 4. What I do to the bottom, do to the top. And then that's it. Just do the multiplication and you're good to go. 3x times 9. Okay. And then now, 8 times 4. It's that 36. And all of that is over what? What's this, 39 or 38? 36. Questions on this? Anybody? Maybe we can reduce this a little bit, pull out 3 up here. That becomes 9x minus 12 over pull it over here. What is that?
I didn't know she was asking about the services. I was like, that wouldn't be on the timesheets, but she gets the timesheets every week.
And the 3's will cancel out,
Yeah,
and that's it.
okay, perfect.
I think I could pull out another 3 too, just looking at this. I could pull out another 3 too. And this is 3x minus 4. Pull another 3. This is 3 times 4. These cancel. So I take this as my final answer, 3x minus 4 over 4. Which one? It is 32. That's what felt wrong. Sorry about that. Whoops. Whoopsie daisy. One of those long days. All right. So then, yeah, that would be it. All right, let's get one more blast from the past so we could like start our lesson. So this is a subtraction question. What should I do first? Tell me. Who remembers what to do? Distribute, exactly. Exactly. That's our first step. Whoops. Hold on. So I want to distribute here, and I want to distribute here. That's simple. 6 times 2, that's our 12x, plus 6 times 1, 6, minus 4 times, negative 4 times x is negative 4x, and negative 4 times negative 5, negative is positive, 4 times 5, 20. And then you want to combine like terms, x's with x's, numbers with numbers, right? So 12x minus 4x, right, is 8x. And 6 plus 20 is 26. And that's it. Any questions on these things? Anything so far? Anybody? Any questions? All right, give y'all another minute. Distribute and combine like terms. That's the secret. All right, let's jump into this real quick. Okay, so it is the same with rational expressions. To add rational expressions, they must have a common denominator. When the denominators are the same, you add the numerators and place the sum over the common denominator, and that's it. Right? So this is real simple because we all know how to do this already. We're just going to look at how to do it with polynomials. That's the difference, right? So rational expression, addition and subtraction. If P, Q, and R are polynomials where R does not equal 0, then P over R plus Q over R is equal to P plus Q over R. And P over R minus Q over R is equal to P minus Q over R. Questions on that? Does that make sense? Okay. To add or subtract rational expressions with a common denominator, add or subtract the numerator and place the result over the common denominator. We always simplify rational expressions. Be careful to factor if possible. After you subtract the numerators, you can identify any common errors. Remember too, we do not allow values that would make the denominator 0. So what value of x should be the excluded in the next example? All right, there's an example. I have 11x plus 28 over x plus 4 plus x squared over x plus 4. What should I do? So, all right, so what do I notice here? I have the same denominators, right? So because I have the same denominators, we're going to leave that the same. And all you're going to do is just add the numerators, right? Very good. So I have 11, sorry about that. I have 11x plus 28 plus x squared over the x plus 4. Here's the trick though. I actually have to factor this numerator just to verify that what's in the numerator doesn't affect what's going to be in the denominator, right? So looking at this, I want a factor of 28. 28, I'm thinking of 7 and 4. So x plus 7 and x plus 4, right? Because 7 plus 4, that's what? Yeah, that's it. 10, 11, yep. Boom. Now I want you to notice x plus 4 and x plus 4 are the same, right? So what am I going to do? Cross them out. So what's my final answer? X plus 7. That's it. In terms of making my denominator 0, the value for x that it would be excluded, right, or not part of an answer would be what? -4. So to get it, take your denominator, set it equal to 0, solve for x. Now you have x is equal to -4. All right? Any questions on that? That's the excluded value. This would be like the final answer. Questions, anybody? All right, you guys try. Same thing. Try that out. Give you guys a minute to try this. Give y'all another minute. Okay, sounds like you found the answer. That's good. That's good. All right, let's take a look. I have the same denominator, so I can add straight across. So I have x squared plus 9x plus 14 over x plus 7. Remember, we got to factor that numerator, right? So we're going to have x here and x here. Two numbers that multiply to 14 and add up to 9. I'm thinking 7 and 2, so plus 7 plus 2. Then we want to divide that by x plus 7. Let's cross these out. What am I left with? X plus 2. Whoops. Now, let's say that I want to know what is the excluded value here, right? Take the denominator, set that equal to 0, right? Just solve for x. That's all you have to do. Solve for x. I'm going to subtract 7 from here. If I do to one side, do to the other. So I have x is equal to -7, right? So this would be your excluded value. All right? So then, all right. Let's try a little subtraction. So remember, before I can subtract, distribute the negative, and then you can combine like terms. So I have 5x squared, and I have the same denominator too, so that's why I'm allowed to just work with the numerator. 5x squared minus 7x plus 3 minus 4x squared minus x plus 9. All over the x squared minus 3x minus 18. Let's combine like terms. 5x squared minus 4x squared will be just 1x squared. -7 minus 1 is going to give me -8x. And then 9 and 3. What's that? 10, 11, 12. All over. Now let's factor the top and bottom just to verify, right, that we don't have anything that can cancel out. X minus 6. Yep. Because -6 plus -2 is -8. -6 times -2 is +12. On the bottom, 18. Thinking about maybe 6 and 3. X minus 6. X plus 3. And if this is confusing, just go back to the AC method. The AC method would always work here. I'm just trying to save time. X minus 6 cancels out, leaving back x minus 7 over, whoops, x minus 2, I'm sorry, over x plus 3. So this is the answer right here. And then, right, we want to look at the excluded values, right? So for the excluded value, just take the denominator, set it equal to 0, factor it, right? And then we just want to set these equal to 0. Solve for x. I'm going to add 6 here, add 6 here. So I have x is equal to 6. I'm going to subtract 3 here, subtract 3 here. Oops. So I have x is equal to -3. Okay, these will be my excluded values. All right. Questions on this? Anyone? All right, you guys try now. Try that out, try that out. Have the same denominator, so we just work with the numerators here. All right. I want to subtract these, right? Remember, before I can subtract it, I must distribute that negative. Also, I notice that I have the same denominator on both, right? So I can just go straight ahead with the numerator. So I have 4x squared minus 11x plus 8. Distribute that negative minus 3x squared. Distribute that negative minus x. Distribute that negative. And next times negative is a positive 3. All divided by the x squared minus 3x plus 2. Let's combine like terms, shall we? Let's combine like terms. 4x squared minus 3x squared will leave you a 1x squared. Negative 11x minus x is going to give you a negative 12x. And 8 plus 3 is what? 10, 11. All divided by squared minus 3x plus 2. Let's factor the top just to verify that nothing is the same on top and bottom, right? Excuse me. I have x minus 11, x minus 1, over. So the factor this is, I have x minus 2 and x minus 1. That's good. Like terms cancel out. Final answer, x minus 11 over x minus 2. All right. And then excluded value. All right. Set the denominator equal to 0. This is going to become x minus 2, x minus 1. Solve for x, right? I'm going to add 2 over here. So I have y is equal to, excuse me, x is equal to positive 2. And over here, I'm going to add 1 over here. I do the one side, do to the other. So I have 8 is equal to 1. Oops, x, sorry about that, is equal to 1. And there you go. It's my excluded value. Questions on this? You will see this for homework. There will be a question where they're asking for the answer of the factor, and they're asking you to find the excluded value. All right, there's no question. Last time we spoke about a really unique trick. I'm gonna bring that back real quick. Okay, add and subtract rational expressions whose denominators are opposites. So when the denominators of two rational expressions are opposites, it is easy to get a common denominator. We just have to multiply one of the factors by -1 over -1. Let's see. I have 7 over d plus 5 over -d. Multiply top and bottom by -1, and I now have 7 over d plus -5 over d. Adding straight across, that gives me a 2 over d. That's it. Questions on that? All right, let's look at an example. Let's start off nice. So I have m squared minus 6m time over m squared minus 1 minus 3m plus 2 over 1 minus m squared, right? So according to the trick, if I multiply this by -1 and this whole thing by -1, let's see what happens. I have m squared minus 6m over m squared minus 1, right? Minus, right? Now I'm multiplying the top by -1, so this is going to become what? This is just the 3m plus 2. Put the minus 1 in front. And over here, I have m squared minus 1. Now that since my answers are the same, right, I can combine like terms, all that good stuff, right? So I have m squared minus 6m. Distribute this, distribute this. This is going to become a negative times negative is positive, 3m, right? And the negative negative times a positive is positive 2. All divided by our m squared minus 1. Let's combine like terms. I have m squared minus 3m plus 2, all divided by, right, m squared minus 1. Keep going. This is what? M minus 2, m minus 1 over m plus 1, m minus 1. These two are the same. So my final answer is m minus 2 over m plus 1. Perfect, perfect, perfect. All right. To find the excluded values, excuse me, I'm going to take the denominator, set that equal to 0. So I have m squared is equal to 1. Right? I'm going to solve for m. So I'm going to have, ooh, hold on. Jump in the gun, jump in the gun. Sorry about that. Yeah, we ain't get there yet. We ain't get there yet. Factor this. And what am I going to have? I have m plus 1 times m minus 1 is equal to 0. Set both of them individually equal to 0. M plus 1 equals 0. M squared minus 1 equals 0. Solve for m. Oops. M minus 1 equals 0. Subtract 1, subtract 1. So I have m is equal to -1. And then I have what? I have m minus 1 plus 0, add 1, add 1. So I have m is equal to +1. And there you go. Those are my excluded values. Let me write that.
I have a question.
Excluded values. Go ahead, please.
So after we find all that top stuff, we just use the denominator to find the excluded values?
Yep, that's it.
Then what would be the point of us doing the top part?
Because you have to add or subtract to get the final answer.
Oh, okay.
Yeah. So in the homework, I'm gonna be asking like both what is the final answer and what are the excluded values. Yeah. This is all building up to when we get to equations. You'll see. You mean like next class? Next class, this will all tie in together. Let me let you guys try one. Go ahead. Try that out, try that out, try that out. So the goal here is to get the denominators to look the same. Once they look the same, do what you know how to do. Combine like terms, add, all that good stuff. All right, let's take a look. So remember, in this situation, I want to subtract, right? But I got different denominators. However, these denominators are opposites. So to fix the opposite situation, all I have to do is just multiply by -1. What I do to the bottom, do to the top. And bam, it's fixed. Now I have y squared minus 5y over the y squared minus 4 minus, and then I'm going to have a -1 times 6y minus 6 over, distribute that, the negative over here, and you're going to see this is going to turn into y squared minus 4. Voila. I have the same denominator. So now I can go about doing my business. All right. So this is going to be, think of this as -1 and -1. This is going to be y squared minus 5y. Negative times a negative is positive. So plus 6y minus 6. Right? What would happen is there would be like a distribution here, then another distribution here to switch it back to the way it was. So I'm just avoiding that by just adding it together. But that's just know that that's what's happening here. On the bottom, I have y squared minus 4. Boom. Let's combine like terms real quick. Combine like terms. So y squared. Now, -5y plus 6y, that's going to be 1y, right? So plus y minus 6 all over the y squared minus 4. Let's factor this out real quick. All right, so this is going to become what? Y plus 3, y minus 2, right? And then on the bottom, we have the difference of two perfect squares. So this is y minus 2, y plus 2. Cross out the like terms. Final answer, y plus 3 over y plus 2. Boom. Let's find those excluded values real quick. All right, so I have a y squared minus 4. Just set that equal to 0. Y squared minus 4 is equal to 0. Right, then I want to factor this. This becomes y plus 2. Y minus 2 is equal to 0. And then very simply, we're going to set both of those equal to 0. Y plus 2 is equal to 0. Y minus 2 is equal to 0. I'm going to subtract 2 from over here, subtract 2. So I get y is equal to -2. I'm going to add 2 over here, add 2. So then I'm going to get y is equal to +2. These will be my excluded values. And that's it. When you're doing your homework, you might just want to separate them by a comma or something. So like -2, comma 2, something like that. And then it'll go through, no problem. All right. Let's take it up a notch, right? But we got to build this up a little bit. Let's build this up a little bit. So first, you want to find the least common denominator of a rational expression. We know how to do it for a number, but we're going to do it for a rational expression now. So when we add or subtract rational expressions with unlike denominators, we need to get common denominators. If we review the procedure we use with numerical fractions, we will know what to do with rational expressions. Let's look at an example. 7 over 12 plus 5 over 18. Since the denominators are not the same, the first step was to find the least common denominator, LCD. To find the LCD of the fractions, we factored 12 and 18 into primes, lining up any common factors in columns. Then we brought down 1 prime from each column. Finally, we multiplied the factors to find the LCD. When we add numerical fractions, once we found the LCD, we rewrote each fraction as an equivalent fraction with the LCD by multiplying the numerator and denominator by the same number. So we are now ready to add, right? So 7 over 12 plus 5 over 18. We factored out the the 12 into 2 times 2 times 3. Factored out the 18 into 2 times 3 times 3. Brought down one number from each column. Boom, boom, boom. 2 times 2 times 3 times 3, which gave us 36. So now our goal was to make each denominator into 36. To turn 12 into 36, we multiply it by 3, which you do to the bottom, you do to the top. Right? To make 18 into 36, you multiply it by 2, but we do to the bottom, to the top. 7 times 3, 21. 5 times 2, 10. So now just add the numerators. 21 plus 10, what's that? 31 over 36. And that's the end of the game right there. All right. Before we jump into what we're gonna be doing, let me give you guys a little bit of procedure. All right, don't want to go into a blind, right? So let's find the least common denominator of rational expressions. Step 1, factor each denominator completely. Step 2, list the factors of each denominator. Match factors vertically when possible. Step 3, bring down the columns by including all factors, but do not include common factors twice. All right? Ooh, that's a good one. Do not include common factors twice. And then write the LCD as a product of the factors. All right? And then do what they're asking you to do. Let's take a look. Let's take a look. Let's take a look. All right. So I want to find the LCD for this expression, for the expressions, excuse me. I have 8 over x squared minus 2x minus 3 and 3x over x squared plus 4x plus 3, right? And I want to write them as an equivalent rational expression with the lowest common denominator. Awesome, awesome, awesome. So let's take a look. So again, this is an expression. I'm not adding or subtracting here, right? I'm just gonna simplify it, right? Oops, hold on. I should really have a pen. I should really have a pen. Okay, so I have 8 over the x squared minus 2x minus 3. And I have the 3x over the x squared plus 4x plus 3, right? What do I want to do? Factor the denominators. Let's factor the denominators. So on the 8, this is going to become what? X minus 3, x plus 1. And for the 3x, very simply, x plus 3, x plus 1, right? Don't worry if you can't get it as fast as me. You'll be given ample time on the test. So don't stress that, okay? But I know you guys can find these factors, no problem, right? Anyway, let's talk LCD now, right? Because that's what they want to know. They want to know what's the LCD, right? LCD, right here, right? So I noticed that I'm looking at the 8 now, right? The one with the 8. I noticed that they have x minus 3 and it has x plus 1. Okay, okay, okay. Now I'm going to look at where the 3x is. I noticed that has an x plus 3. I don't have an x plus 3 here. Let me add that over there. But I do have an x plus 1, right? Now you see, if I put the x plus 1 into the LCD over here, now I'm adding a repeated value. And we don't want that. We don't want no repeated values, right? So very simply put, I want to make this clear. I have 8 over x minus 3 times x plus 1, right? And what am I missing from the denominator underneath the 8 to make it into the LCD, which is x minus 3 times x plus 1 times x plus 3? I'm missing that x plus 3, right? So that's what I'm going to multiply right here. I'm going to multiply this by x plus 3, very simply. But what I do to the bottom, I have to do to the top. So let's do it to the top, x plus 3. Just like that, right? Give me 1 second. On the other side, right, I have the 3x over the x plus 3. and the x plus 1. Now, what am I missing from the in the denominator of the 3x, right? That I have the x plus 3 and the x plus 1. What am I missing to make it look like the LCD? I'm missing the x minus 3. I'm missing that x minus 3. Let me do that. And when I do to the bottom, I do to the top. That's it, right? So let's recap real quick. What did the question ask us for? It says find the LCD for the expression. Boom, here goes your LCD right here. Boom. Right? And then it says rewrite them as an equivalent rational expression with the lowest common denominator. There you go. That's that. That's this right here. Let me just close that up. And that's it. Any questions on that? Obviously, if I was going to add or subtract, that would be distributing the numerators, and then combining like terms and then factoring again just to verify that nothing got lost in no that there's no repeat factors in the numerator as they are in the denominator, right? Absolutely. Absolutely. I'm gonna let you guys try one real quick. Try that out. This is on your homework as well, where they're gonna ask you for the just the plain old LCD. Please read the question, right? Sometimes it's not asking you to add or subtract, just asking you like, give me the LCD, and that's it. All right, let's give this a whirl, right? So I have 2 start off like this. I have 2 over x squared minus x minus 12. And I have 1 over x squared minus 16, right? Let's start by factoring these real quick before we jump into anything. This is going to become 2 over, right? This is going to be what? X, I'm thinking minus 4, maybe x plus 3. That looks pretty good. And over here, this is going to be really simple. Difference of 2 perfect squares. So x minus 4, x plus 4. And then, of course, you know, what do they want? They want the LCD. So here we go. Here goes the LCD. Take one of them, right? So I'm going to take the first one. I have x minus 4 and the x plus 3. And then I'm looking at the second one. This is the fraction that has the x minus 4 and the x plus 4 on the bottom and the 1 on top. And I'm looking at my LCD and I'm asking myself, what does that fraction have that I don't have? It has an x plus 4. So we're going to add that up over here. X plus 4. There we go. Now here's the thing. They want us to have an equivalent, right? Rational expression. So let's make that out. Let's make that out. So I have x minus 4, x plus 3. Now I want to have the same kind of denominator as the LCD, right? For the 2, right? I have the x minus 4 and I have the x plus 3, but I'm missing that x plus 4. I have x minus 4, excuse me, and I'm missing the x plus 4. So I'm gonna multiply that by x plus 4. But what I do to the bottom, gotta do to the top. Just like that. Just like that. All right, now I'm gonna do the 1, right? And on the bottom of the 1, I have x minus 4, and I have x plus 4. But I'm missing something, right? I'm missing something. I want my denominator to look like the LCD. Now I have the x minus 4 and I have the x plus 4, but I'm missing that x plus 3. So I'm going to multiply this by x plus 3. What you do to the bottom, you got to do to the top. X plus 3. And that's it. Those are my 2 answers right there. All right. Is there any questions on this from anybody? Anybody, any questions? This would be like A and this would be like B, for example. No questions? All right, let's keep it moving then. Let's keep it moving. It's not so bad, right? Not so bad. All right. Here's what the point of all of that was. Here's what the point of all of that was. I want to get back to adding and subtracting real quick. Let's get back to adding and subtracting real quick. So I want to add a rational expression, right, that has an unlike denominator, right? Meaning that the denominators are not the same, right? And I'm going to use this same process to do it. Watch. Hold on, let me just make sure I have the right pen. Okay, so I have 3 over, let me put this in parentheses, the x minus 3, plus I have 2 over the x minus 2, right? So what I want to do, right, I'm going to do it in green. I want to find, should I do it in green? Let's do it in rainbow, right? I want to find the LCD. That's what I want to do. I want to find that LCD, right? Very simply, I have x minus 3 times the x minus 2, right? These two denominators are different, so I can just kind of put them together like that, and that's the end of it, right? So now that I found the LCD, right, I want to make these two expressions have the same denominator so I can add They're numerators. That's the name of the game right here. That's the name of the game, right? So I have the x minus 3. I'm gonna multiply this because I want the denominator under the 3 to look like the LCD. So I'm gonna multiply this by x minus 2. But what I do to the bottom, I gotta do to the top. Over here, now I'm looking at the 2, right? I have x minus 2 in the denominator, but I don't have that x minus 3 to make it look like the LCD. So I'm going to multiply this by x minus 3. But what I do to the bottom, I got to do to the top. Bam. Right? After that, you already know what's going to happen, right? Going to distribute, combine like terms. All that good stuff is about to go on right now, right? So let's take a look at that, right? Gonna distribute, combine like terms. So now let's check this out. This is gonna be 3x minus 6 plus 2x minus 6, right? Just distributing all over the LCD. So x minus 3, x minus 2. Let's combine like terms, shall we? Let's combine like terms. 3x plus 2x, what's that? 5x. Negative 6 minus 6 minus 12. All over the x minus 3 and the x minus 2. That's it, right? 5x minus 12 can't factor that any further. So we could call it a day at that. And that's my answer. And that's how you add, right? Rational expressions that have different denominators. Is there any questions on this? Any at all? Any questions? All right. I know this is really, really exciting. I want to give you guys a chance to try it for yourself. All right. So let me give you guys one. There you go. Remember, find the LCD, and then I want you to add the two expressions together. Okay. Try that out real quick. Try that out. Let's take a look. First thing I do, want to find that LCD, right? LCD in this case will be very simply the x minus 2 times the x plus 3. What you do to the bottom and do to the top. I'm going to multiply this by x plus 3. I'm going to do to the bottom, do to the top. I'm going to multiply this by x minus 2. I do to the bottom, do to the top. Now let's put it all together, shall we? I have 2 times the x plus 3 plus 5 times the x minus 2 all over the LCD, x minus 2, x plus 3. Let's distribute. All right, and what do I have? I have 2x plus 6 plus 5x minus 10 is all over the x minus 2 and the x plus 3. Let's combine like terms, shall we? So 2x plus 5x is what, 7x? And 6 plus negative 10, that's like what, negative 4? All over x minus 2, x plus 3. This right here is your final answer. Questions on this? Anybody? Any questions?
One second to copy it.
Sure, take your time, take your time.
There. Thank you.
You're welcome, you're welcome. All right. Just want to give you all a little bit of procedure real quick. Even though we did 2 examples. So this is how to add or subtract rational expressions. Step 1, determine if the expressions have a common denominator, right? If yes, go to step 2. If no, rewrite each rational expression with the LCD. So find the LCD, rewrite each rational expression with an equivalent rational expression, all right? No, as an equivalent rational expression with the LCD. Step 2, add or subtract the rational expression. Step 3, simplify if possible. All right. That's our procedure. Let's try this out. Here's another example. So I want to add 8 over x squared minus 2x minus 3 plus 3x over x squared plus 4x plus 3. The first thing I notice is I do not have the same denominators. So I'm going to rewrite this, right, while factoring the denominators. So this is going to be what? 8 over This is gonna be x, right? I'm thinking x minus 3 and x plus 1 plus, this is gonna be 3x over, this is gonna be what? X plus 3 and x plus 1. Now, what do I want to do? I want to find the LCD. Let's find that LCD. So I'm just going to take the first one. I have x minus 3, x plus 1. When I look at the second denominator, which is the x plus 3 times the x plus 1 under the 3x, I notice I don't have an x plus 3, my LCD. So that's it. That's the LCD. Now that I have the LCD, let's simplify this, right? So I'm going to multiply this by the x plus 3, right, to get the same denominator. But what I do to the bottom, I got to do to the top. And then I have the x plus 3 and I have the x plus 1, but I'm missing x minus 3 over here. So what I do to the bottom, do to the top. So now, right, let's distribute, combine like terms, all of that good stuff, right? 8 times x is going to give me 8x plus 8 times 3, what's that? 24 plus 3x squared minus 9x all over the denominator. All right. So now let's put this together, combine like terms, all that good stuff. So 3x squared minus x plus 24 all over the x minus 3, x plus 1, and the x plus 3. Okay. Let's factor this one. 2, 2, 2. If it is factorable, let's think about it for a second. It's going to be 3x is x, 24. Six and 4 doesn't work. Let's figure this one out. Eight and 3. Could that work? That's it. 8 and 3. So minus 3 here. Plus 8 over here. That's it. Nine. Boom, boom. Yup. Ooh, hold on. That's not it. Hold on. Got that wrong. Let me think. You know what? Looking at this, I don't think this is factorable. Or let me say that a different way. It is factorable, but we haven't gone over how to do that as yet. But we will. But we will. So this will be my final answer right here. All right. If you guys tried the AC method, you won't get it. But we're gonna discuss another way on how to get it later on in the course. So that would be the answer for that. I'll let you guys give it a try. There you go. Try that out, try that out. Okay. Little complicated. We have m's, but I noticed that in this question we have different denominators. I have m squared minus m minus 2 in one, and I have m squared plus 3m plus 2 in the other. So let's start off by factoring the denominators. So I have 1 over, this one is m minus 2, and m plus 1, plus this is going to be 5m in the numerator, and this should be what? M plus 2 and m plus 1. Let's look at what the LCD is, shall we? So I have LCD All right, m minus 2, m plus 1, m plus 2. That's our LCD. Just take the first one, then we look at the second one and ask ourselves, what does the second one have that we don't have? Put it all together, boom. That's your LCD. So now I'm looking at 1 over the m minus 2 times m plus 1. I'm missing something from there. I believe it's the m plus 2. What you do to the bottom, you do to the top. For the other denominator, I have m plus 2, m plus 1. I feel like I'm missing the m minus 2. And what you do to the bottom, you do to the top. And then you already know what's going to happen, right? Distribute, combine like terms, all of that. All right. Let's look at what we have. I have m plus 2 plus 5m squared minus 10m. Right? And all of that is over the LCD. Let's combine like terms. I get 5m squared minus 9m plus 2. All right? All over m minus 2. This right here, just thinking about it, can't be factored. So I'm good to go. Questions on this? No questions? All right, let's keep it moving. Got some more examples for us. A little bit different this example though. I want to subtract. So we're going to factor one of the denominators. I have 8y over so let's look at our LCD. LCD, y minus 4, y plus 4. This is the only one missing something, y plus 4, y plus 4. All right, let's knock this out. So I have 8y minus 4y distributing minus 16 all over y minus 4, y plus 4. Let's combine like terms. 4y minus 16 over the y minus 4y plus 4. I'm going to factor that one more time, factor that 4 out. So I'm left with y minus 4. So let's look at what we have. I have 4 over y plus 4 because of the common factor. Questions on this? Anybody? Any question on this? It's clear? What you guys try? Try this out. Try this out. All right, let's take a look. Again, I want to factor this. Make it simple. This is 2x over the x minus 2, x plus 2, minus 1 over the x plus 2. I want to find my LCD. Take one of them, x minus 2, x plus 2. Add what you're missing into it, and that's it. So now the only one that's missing something is over here. This is the x minus 2. What you do to the bottom, you do to the top. And that's it. Let's combine like terms right here. I'm going to have 2x minus x plus 2 all over the x minus 2 and the x plus 2. Yeah, that's gonna be it for that one. Questions on that? Any questions at all? We good? All right, let's try it out. All right, let's get this. So I'm gonna factor this out real quick. So I have the 3n minus 9 over the n plus 3 and minus 2 minus the n plus 3 over the 2 minus n. Okay. Let's talk LCD. Well, before I do that though, right? I'm missing something here, right? Let's look at this LCD. We'll take the first one. I have n plus 3 times n minus 2. Right? This is an opposite, so I'm going to multiply this by -1, but what I do to the bottom, I do to the top. So now let's look at what I have. I have 3n minus 9 over the n plus 3 n minus 2. And I have the -1 times the n plus 3 over the n minus 2 times -1. Okay. Oh, whoops. Actually, I don't have that, so I distributed it. Okay. LCD is n plus 3 times n minus 2. I'm missing the n plus 3. What you do to the bottom, you do to the top. All right, let's combine like terms, get this over. So I have -3n minus 9 minus, open parentheses, n squared plus 6n plus 9. All over the n plus 3. And excuse me, minus 2. Okay, let's distribute, combine like terms, all that good stuff. -n squared. Let's see. Plus 3n Let's see. Hold on one second. There we go. And then negative 9 minus 9 minus 18. Right? That should be about it. Should be minus 9, I think. Yep. Okay, that looks good. Greatest common factor over here is -1. Make that n squared plus 9n plus 18. Let's factor this out. Thinking 6 and 3, 6 and 6 is 12, 6 and 7, 18. Yep. This is -1 n plus 6 n plus 3 all over n minus 2 n plus 3. There we go. Cross out the like terms. Final answer, -1 n plus 6 over n minus 2. That's it. Questions on this? Any questions? All right, you guys try. Remember, it's an opposite. Multiply by -1, top and bottom. Try. right, let's try this out. I have 3x minus 1. I'm going to factor the bottom. It's going to give me an x minus 6, x plus 1, minus 2 up the top, times 6 minus x. All right. What do we have? 3x minus 1 minus 2 times the x minus 6. When you distribute this, you see that your answer is actually x minus 6. All over LCD. Times it's -1. No. Actually, that's it. This should be positive. And then now distribute combine like terms, 3x minus 1 plus 2x minus 12 all over the x minus 6, x plus 1. Combine like terms, this is 3x squared plus 3x minus 12 over the x minus 6, x plus 6. This should be what? 3x That's to add up to 3. What do I have? Thinking. All right. Let's do a greatest common factor first before we do that. So 3 on the outside, x squared plus x minus 12 over the x minus 6, x plus 1. Okay. This is 4 and 3, right? So 3 times x plus 4, x minus 3. That sounds better. X minus 6 times x plus 1. Nothing to cross out here, but we do have to factor it like this to get our final answer. And we good to go. Questions on this? All right, let's try some more. Oops, sorry about that. All right, same kind of question, right? I'm asked to subtract these rational expressions. I'm going to rewrite this as 4 over, I'm going to factor that. This is a plus 5, a plus 1, minus the 3 up top. This is a plus 5, a plus 2. Now let's find the LCD. LCD, I'm going to take the first one, a plus 5. Hold on. Sorry about that. Times a plus 1, right? Looking at the second one, I'm missing the a plus 2. That's my LCD. So let's do it. I'm gonna multiply this by a plus 2. What I do to the bottom, do to the top. And I have a plus 5, a plus 2, and I'm going to multiply this by a plus 1. What I do to the bottom, I'm going to do to the top. All right. You already know what's going to happen after that. We're going to distribute, combine like terms. Hold on. Distribute. And combine like terms. So what do I have? I have 4a plus 8 minus 3a minus 3, all divided by our LCD. A plus 5, a plus 1, a plus 2. Boom. Right? Combine like terms, what do I have? I have just a by itself plus 5. Right? Combining like terms, which is simply just adding. On the bottom, I have the a plus 5, a plus 1, a plus 2. Watch what's going to happen. Cancel out, cancel out. So my final answer, let me just bring that down over here. My final answer will be 1 divided by a plus 1 times a plus 2. Whew. And that's it. Any questions on that? Anybody? All right, let me let you guys try one. I'm excited that everybody's getting this. Homework for this section has been posted, so please, right after class, just try and do it. I will be in tutoring online today. If anybody wants to join, right? You know how to make the appointment, right? You guys are welcome to come. Please allow me a few minutes before we post the recording. All right, I need a couple of minutes to have it downloaded. Give me, and I'm exaggerating. Give me like an hour, maybe 2 hours to get it up posted for you guys. Once again, if you did not get your test back and you would like it back, please come see me in tutoring. Otherwise, I will give it back to you on Tuesday. Right? I will be in tutoring on Friday, Saturday, and Monday. Right? So whenever you're free, on Saturday is the only special day. I'll be there at 3, so from 3 to 6. If you come earlier than that, I won't be available. But other than that, I'm good to go. All right. Once again, I hope everybody got their pantry stuff this week. All right. If not, we got pantry in another 2 weeks. We're still building up to our test. We haven't covered all the material for our test as yet. Okay, so we're looking at some time in November. Please try to stay on top of your homework, everyone. I know this thing kind of builds, so do your best. It's okay if you can't answer everything. That's what tutoring is for. Go there and ask for help. If you can't make it on in person, remember that tutoring is also online as well. So you guys can take advantage of the 2 modalities. Give you guys a few minutes to try that. All right, let's take a look. Last question for the day. All right, I have 3. I want to factor this, so I'm going to have a b minus 5, b plus 1. Negative sign here, we're going to have a 2. I'm going to factor the other side. This should be a b minus 5 and a b minus 1. Let's take a look at the LCD, shall we? So the LCD is going to be the b minus 5 times the b plus 1, multiplied again by the b minus 1. So now remember, I want all the denominators to be the same so that I can subtract. So I'm going to multiply this first one by what's missing, and that's the b minus 1. But what I do to the bottom, I do to the top. I'm going to multiply the other expression, which has b minus 5 and b minus 1, by the b plus 1, because that's what I'm missing. What I do to the bottom, do to the top. After that, we're going to distribute, combine like terms, all that good stuff. So 3b minus 3 minus 2b minus 2, all divided by the LCD, which is the b minus 5, times the b plus 1, times the b minus 1. Combining like terms, what do I have? 3b minus 2b is just plain old b. And then negative 3 minus 2 is going to give me a negative 5. All over the b minus 5, b plus 1, b minus 1. That being said, cross out the like terms. What do I have? This final answer, I have 1 over the b plus 1 times the b minus 1. And that's it. That's my answer. Is there any questions on this from anybody? We all good with adding and subtracting rational expressions? Questions? Anybody? All right, I guess we could just wrap it up right there. All right, once again, come see me in person if you would like the test back before Tuesday. Otherwise, I'll give you back your test on Tuesday. You can still do your test corrections. Just give them back when you get them done. Right? Please stay on top of your homework. Everything has been posted. All right. There's no penalty for trying a question. Just get all the homework done. Right? Utilize tutoring. Right? It's okay if we can't get all the questions by ourselves, right? That's why we have help. All right. And that's about it. All right. I hope you all have a great weekend. All right. And I'll see you all on Tuesday if you don't come to tutoring. All right. All right. Have a good weekend. Have a good weekend. All right. Talk with you guys soon. Yes. Yes, you can. Yeah, I'll accept the test corrections anytime in the semester. So yeah, Tuesday is fine. Remember to get the tutor signature and everything. Okay. All right. All right, y'all. Have a good night.